Welcome back this week. I hope you guys had a nice weekend and are looking forward to the long weekend next week. So just make sure you remember Monday, a week from now, there is no class to celebrate Emancipation Day. Woohoo! I'm a little sad that Juneteenth is being corporatized and monetized, but I'm really happy that we have acknowledged this as a significant holiday in the federal government, and so I am all in favor. Um, my feelings are similar to Pride Month, which is there's no reason that corporations need to benefit from this date. However, I'm still happy we're recognizing it. All right, so today we're talking about the average rate of change in the difference quotient. And so really there's a couple of places that we are going to use average rate of change rather than having slope, and same thing with difference quotient. So the difference is these are just two different ways to think about and talk about slope. But if you're dealing with a line, it's all slope. And if you are dealing with a shape of a graph that's not a line, then it's just the slope of a segment connecting 2 points on that line. So we'll talk about different conceptualizations of that today. And then we are going to do a performance task that I think is actually pretty cool. It's one of my favorites. And so that's it. During the performance task, I'm going to need a couple of volunteers to read a paragraph and a reading that we're going to do. So if you are somebody who feels comfortable reading out loud, then if you would put your name in the chat, I can call on you. I can assign you a paragraph. If you're interested in seeing what you'd need to read, it's in OneNote under our performance tasks under performance task 6, just so that you can see. And I'll bring that up later, but just a heads up, I'm not going to ask anybody to read that isn't comfortable. And if nobody's comfortable, I'll read it. Okay, so we are just going to connect some prior knowledge here. Slope can be used to find the rate at which like a line is increasing or decreasing. So it's the tiltiness of a line, change in y over change in x. We have this little slope formula that we have used before, and it just is a difference in the y's over the difference in the x's. That's how we calculate our slope. Average rate of change works exactly the same way. All right, if our two inputs for x, here, I'm gonna make a little graph. Say our graph looks like this, and I want to find the average rate of change from x equals a to say x equals b. I'm going to basically find the slope of the line that connects them, right? So this is my x2 and this is my x1. All right, and then if my output for those inputs are here, this is just my y2 and my y1. So what we get for average rate of change is the slope of the line segment connecting 2 points, but we need to know those 2 points. I have my first and second A, or my first and second X, it's A and B. I'm looking at the average rate of change over that interval. So average rate of change requires at least 2 points, and it's usually like a change over time or a change with respect to the x variable, how y responds. It's still just slope, and I hope that it looks familiar enough for you to understand. But when we look at the difference quotient, it takes it a step further. The difference quotient is used to find the instantaneous rate of change for a curve that's not a line, a line or a curve, and it's found in calculus using a formula called the derivative. The derivative is this calculation of instantaneous rate of change. So I'll talk about exactly what that means. You are not calculating derivatives today. It will be the same as finding slope. It's just that in future math classes, you need to be familiar with this notation and this derivation so that when it's time to find the derivative, you aren't so worried about the algebra. You can actually focus on the concept at hand. So change in f over change in x for a function f of x. What we're going to do is this. We are going to consider a function kind of like the jiggly wiggly one that I drew before. And I'm going to be looking at 2 different points on that line. except instead of calling them A and B, I'm going to call them X, and this will be X plus H. All right, so what I want to know is the reason I have X and X plus H is that in the derivative, what I'm going to do is I'm going to let this distance shrink down to 0 so that I basically am getting closer and closer to the rate that's happening, like the slope of this tangent line. At that exact point, what is the slope? So I need to be able to let my distance from H or from X shrink to 0. Because of that, I'm just going to define my difference in terms of X and how far from X this other arbitrary point X plus H is. So it's just some distance away from X. So what I do is this is my sorry, the reason I paused right here is that this is actually just I just have written this incorrectly. And so like the reason that I'm struggling with this for just a second here, hold on. Let me just make sure, let me see exactly where I wrote it wrong, because I just want to make sure that I get this right. That's where the problem is. Okay, so I knew I had a problem. I just wasn't sure where it was. It's not, this isn't f of h, it's f of x. There we are. All right, so the reason that it's like that, there we go. All right, so this is like over x plus h minus x, so that I wind up, when I simplify these, just getting x. So this is really the same, sorry. So the reason that I wanted to stop that is that I knew I had something incorrect on this slide, and I didn't want it to affect what we know. Our input is still, this is still like my x2, and this is my x1. When I simplify them, x plus h minus x, my x's cancel and I just get h in the denominator. But the reason that it works like that is I still do have x2 minus x1, and this is just y2 minus y1. It's just a matter of how it's written and the application that it's used in. So it's still slope, it's still y2 minus y1 over x2 minus x1. You just are taking here, this is my x comma f of x point, and this is my x plus h comma f of x plus h point. So this is my x2, y2, and my x1, y1. All right, so it's still slope. There's nothing different. It's just another way to look at it and another way to write it, and the algebra is a little more intense, okay? But we can use it to find the average rate of change between 2 points on a scatter plot or on a graph that's not a line. So again, I would just pick one of my points and call it x. And I would pick another one of my points based on like what I'm choosing and why, and I'd call it x plus h, so that the difference is just the difference, and the change in x is just positive h, all right? And then I'm going to take my y values. This is f of x plus h. This is f of x. And I'm just finding the difference in my y's. I know I just wrote that above, but I just want to make sure it's very clear. This is my change in x. And these are my change in y. Okay. And so we can do this. This is also a way, like some of the problems that you're going to see are sort of like finding the line of best fit through a scatter plot. The line of best fit is not calculated by just picking 2 points and finding the slope between them. But if you can find 2 points that follow the trend of the graph or are like typical of the way that that graph is changing, this is a simple way to eyeball the rate of change or the line of best fit for a scatter plot. But you would normally use statistical software to actually calculate that. And here's how we apply it. Later, you're going to see this again. It's supposed to be an X, not an H. I need to fix this on my original slide. In calculus, you will learn about the derivative, which is the instantaneous point at X, like the slope of a single point. And the way we do that is we define this concept of limit, which is basically like as the distance between X and X plus H shrinks to 0, what is that slope? And it'll be the slope of a tangent line, and it's a whole process. You'll have to learn about limits. You'll have to learn about derivatives. That's all in Calc 1. But if we were going to write the equation of a line using the difference quotient, right, then I could use my point slope form. I'd just do it with X and f of X and X plus H and f of X plus H, so that I would get my Y minus f of X plus H equals my slope times X minus X plus H, which is just H. I don't even need to write that. This is just kind of how I could use the difference quotient to write the equation of a line. I mean, I'd have to add my f of X plus H to both sides to solve for Y and simplify, but that's fine. These are just points, and so they would actually be number values and not expressions, so it's easy peasy. All right, so what we're going to do today is apply the difference quotient to an interesting context. So as a whole class, I want to turn to performance task 6. Why isn't this updated? There it is. And we're going to talk about New York's controversial stop and frisk policy. So is there anybody that would like to volunteer to read any of this? Hold on, I'm going to close it and reopen it because OneNote's being OneNote. So, because we'll just go paragraph by paragraph. And if nobody wants to, like, I'm just give you a couple seconds. Anybody want to read in the chat? That's awesome, Lauren. I appreciate it. Thank you, Drew. Thank you, Brandon. I'll take one. Thank you, Vermin. Do I have 2 more? If not, it's okay. I'll read the last 2. It's no big deal. I don't want to like give you pressure, but it's easier to stay connected to the text when you hear people reading it out loud because you're like following along with what they say. And a lot of people just skim read and don't really read when you ask them to read. And so, all right. So Lauren, why don't you go ahead and begin? If you want, you can open it up on your own OneNote if this is difficult for you to read, but it's fine otherwise.
Okay. The situation in which a police officer who is suspicious of an individual detains the person and runs his hands lightly over the suspect's outer garments to determine if the person is carrying a concealed weapon is called a frisk. One of the most controversial police procedures is the stop and frisk search. This type of limited search occurs when police confront a suspicious person in an effort to prevent a crime from taking place. The police frisk, also pat down the person for weapons and question the person.
Thank you very much. All right, Drew, if you want to take over. I mean, before you do, actually, I think you guys have seen like a frisk. You see people say spread them, and then the cops go. Fall. It happens at TSA. It happens more frequently than I'm comfortable with in my life too. Sometimes it happens at a bar. I mean, it depends on how short your skirt is as to whether or not harassers feel entitled. I guess I don't even know. So now we're going to talk about the difference between a stop and a frisk and what stop and frisk is. So take it away, Drew.
A stop is different from an arrest. An arrest is a lengthy process in which the suspect is taken to police station and booked, whereas a stop involves only temporary interference with person's liberty if the officer uncovers further evidence during the frisk. The stop may lead to an actual arrest, but if no further evidence is found, the person is released. Unlike a full search, a frisk generally limited to patting down of out of the outer clothing. If the officer feels what seems to be a weapon, the officer may then reach inside the person's clothing. If no weapons is felt, the search may not intrude further than the outer clothing.
Thank you very much. So you can see like this is in particular, this happened in New York City. And so there were a lot of people who were being stopped and frisked. So the question comes down to like, is this like a legal search and seizure? Brandon, can you read through that paragraph for us?
Though the police in New York City have long followed the practice of stop and frisk, it was not until 1968 that the Supreme Court evaluated it under the Fourth Amendment's protection against unreasonable searches and seizures. Under Fourth Amendment case law, a constitutional search and seizure must be based on what is probable cause. A stop and frisk was usually conducted on the basis of reasonable suspicion, a somewhat lower standard than probable cause.
Yeah, exactly. And in 1968, the Supreme Court addressed the issue in Terry versus Ohio. In that case, an experienced plainclothes officer observed three men acting suspiciously. They were walking back and forth on a street, peering into a particular store window. The officer concluded that the men were preparing to rob a nearby store and approached them. He identified himself as a police officer and asked for their names. He was unsatisfied with their responses, though, and he subjected one of the men to a frisk, which produced a gun for which the suspect had no permit. In this case, the officer did not have a warrant, nor did he have probable cause. He did suspect that the men were casing the store and planning a robbery, but the defendants argued that the search was unreasonable under the Fourth Amendment because it wasn't supported by probable cause. All right, Furman, you want to take it over?
The Supreme Court rejected the defendant's argument. The court noted that stops and frisks are considerably less intrusive than full-blown arrests and searches. It also observed that the interest in crime prevention and in police safety require that the police have some leeway to act before full probable cause has been developed. The Fourth Amendment's reasonableness requirement is sufficiently flexible to permit an officer to investigate the situation.
Absolutely. So at that time, this was back in 1968, the court did not reject the stop and frisk policy as being unconstitutional. They were concerned that requiring probable cause for a frisk would put an officer in unwarranted danger during the investigation. And the sole justification for a frisk, said the court, is the protection of the police officer and others nearby. Because of this narrow scope, the frisk must be reasonably designed to discover guns, knives, clubs, or other hidden instruments for the assault of the police officer. As long as the officer has reasonable suspicion, a stop and frisk was found to be constitutional under the Fourth Amendment. But after that, one of the biggest arguments surrounding stop and frisk was that some folks, including the mayor of New York City, Mike Bloomberg, at the time of publication of this article, which was in 2016, believed that it helped to it was not 2016, it was like 2013 when the original article was written. One of the biggest arguments surrounding stop and frisk is that some people believe that it's helped to significantly decrease crime, but others say that crime had already begun to decline prior to stop and frisk and that it wasn't proven to shrink the crime rate. I will tell you that this stop and frisk was overturned ultimately by the Supreme Court as being a violation of illegal search and seizure. And that came down to evidence that was produced in court that showed that the stop and frisks were biased and that they were not productive. And so we will talk about that at the end. But for now, we're just going to evaluate this one claim here. This says that some argue that it helped to significantly decrease crime, and others say stop and frisk was not responsible for the reduction in crime rate. So what we're going to do is evaluate a few graphics that were provided by the coverage of this item in this bump article. All right, and so we're going to look at this graph, and this is what we're going to kind of do in your teams. We're going to try to prove using the difference quotient or the average rate of change, really average rate of change, whether or not the stop and frisk was responsible for reducing the crime rate. So in particular, here is a nice little example. So our red line on the graph below is the murders. So murders for every 100,000 residents. So it's like a percentage, right? So like what we have all of these in the left, like the y-axis is percent rate, right? Or frequency, percent frequency. Crime rate, or yeah, it's a rate out of per 100,000 residents. I know that I just said that a little awkwardly. Our violent crimes are the yellow line, and stop and frisk was instituted by Mayor Bloomberg, and then it was actually stopped later at the end of this graph was like the end of stop and frisk, like when it was overturned by the government, right? Or by the Supreme Court. So what we want to do is you can notice that around about here, it looks like the trend in stop and frisks, like if I go from if I'm just looking maybe at the midpoint of those lines and the midpoint of these lines, right? I can kind of see, I have one slope, right? And if I look at the midpoint between these lines, actually not even there, at the beginning and end of Mayor Bloomberg's tenure, we have another slope. And what we want to do is try to make some argument that actually says what the average rate of change was, or the average crime rate, so that we can compare the crime rates and make a formal argument. So what you're going to do in your teams is figure out how you're going to label your x-axis. For example, since we're going to be dealing with multiple time periods, you may want to define x to be or years since 1990. That would make this x equals 0 at 1990, and then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. X equals 10 would be at the year 2000. This is x equals 20. This would be your x equals 21, 2, 3, 4, 5. But we'll go back a little bit. There we go. All right, so that's one way that you can do this. Our y values, you're going to have to look up here to get the exact scale for y and to try to understand exactly. This is 16 out of 100,000. This one is 1,200 out of 100,000. So if you're trying to compare those numbers, you may need to, write the y scale as a decimal. And so what I would like you to do is work in teams. I'm going to put you into breakout groups, and we're just going to spend about 5 minutes to come up with the average rate of change. All right, so I'm gonna sort you into breakout rooms. If you notice on here, we have rooms 1, 2, 3, 4, and 5. Doesn't look like it's rooms 1, 2, 3, and 4, and 5. I don't know why. It is on mine. Let's see. It says room 4. Why is it? Okay, there. Okay, y'all saw. Anyway, so the breakout room that you're in, make sure that you go to that tab. And inside of these, it just has the problems. Okay. And so you're going to want to try to answer tasks 1 and 2. I will grade this from this paper, so you don't have to turn it in. I will just go and grade, make sure you write the names for each person in your room so that I can assign the room a grade. Okay. And I'll be popping into breakout rooms. I really would like you guys to think about this problem together and not just work it individually. I should hear some conversation. Obviously, you don't have to turn on your camera if you don't want to, but I would ask you to unmute yourself. All right, so I'm going to make 5 breakout rooms. And I'm going to open them up. So you guys can go ahead and join them now and go to OneNote to see what your groups are. What up, Raf? Ashlyn, Shandavia, Sam, y'all need to join your breakout group. Cool. Welcome back, y'all. I think everybody else will start coming around. Yeah, yeah. Okay, so as you guys were working, rather than really popping into rooms, I just popped into the pages on OneNote and added notes as you were writing, which I'm sure you noticed. And I saw a lot of things. I think the most effective strategy I saw some people just use like the rate. They said, okay, so this happens here at 2002. So if I come over here to 2002 and over to here at 2002, people tended to look at this rate versus this rate and this rate versus this rate to make the argument, because the scale was easier to compare, just to say, hey, before stop and frisk, the decrease in the rate at which murders were decreasing was this, whereas the violent crimes was this. However, when stop and frisk was implemented, we still see a reduction in violent crimes and murders, but the average rate of change is smaller, meaning that it's a less fast rate of reduction. So yes, stop and frisk, especially if you just look at over Bloomberg's tenure, which is when stop and frisk was enacted, yes, there was a reduction in both violent crimes and murder rates. However, I wouldn't say that it's attributable to stop and frisk because it seems like that was an ongoing pattern, and in fact, it's slowed down. Now, this graph doesn't tell us why it's slowed down. That's the thing about statistics, is you can only answer really the questions that are in the data that you have, and writing, like coming up with reasons, requires a lot of theory and a lot of research, right? But just looking at the numbers, you can see that I don't believe that the crime rate reduction is a sufficient argument to justify stop and frisk. So it doesn't mean it's not, what was said by Bloomberg was not wrong, because Bloomberg actually claimed in one of the articles that I tagged there, Bloomberg actually claimed like, hey, this is working. We need this. This is reducing violent crime and reducing murders. I don't think that there's evidence of that. However, what I am going to do now is I'm going to share a screen. And what I'd like to do is just talk a little bit about how this was actually overturned. And so to do that, I'm going to go to an infographic that was made by the Brooklyner magazine. And what it is it's a beautiful dynamic infographic that was made not by mathematicians and statisticians, but was made by journalists at this magazine with the hope of contributing to the Supreme Court case. And it worked. Like this was data that was presented in court. It's using publicly released data from New York City. So it's the police's data. And each of these dots represents 1,000 stops. And so in this dynamic infographic, as I click through these titles up here, we're going to see the dots move into different categories based on some questions that are being asked about the stops. So in the first thing that we talk about is where in Brooklyn did the stops occur? So Brooklyn has a variety of boroughs, which are like neighborhoods. And these are the 5 boroughs that make up New York City. And we have the borough of Manhattan, Brooklyn, the Bronx, Queens, and Staten Island. Each of these boroughs has distinct demographics and characteristics of the people who make up the population within these boroughs. I keep wanting to say bureau because I've been writing a lot for my dissertation this week, and I've used a lot of data from the Bureau of Labor Statistics, and so I'm all messed up. So you can see that the majority of the stops were in Brooklyn, with Manhattan and Queens and the Bronx coming in second, and then Staten Island being the least. And we'll come back to that idea in a moment. But if you look, you can see also, so what was the suspect's race? Right, overwhelmingly not white, Asian, or unspecified. We have a mixture of Black Hispanic, and white Hispanic. All right, you can see just from the police's data, these people were stopped more frequently. Well, maybe they were stopped more frequently because they were breaking the law more frequently. Like, I'm not trying to say that just because they were stopped more frequently, we have a problem, but we can go in here. It's just giving us some information about the suspects. Overwhelmingly, these were young people, in particular, 16 to 40, really 16 to 29, but 16 to 40 is the biggest group. Nope. And overwhelmingly, they were men. There were some women, but mostly men. So this just gives us some demographics. It's not really making an argument yet. It's just saying, hey, look, here's who was stopped. When we talk about the stops themselves, they have the data divided into the reason for the stop, whether or not they were frisked, and why they were frisked, and whether or not the officer used physical force. Using physical force here means that somebody didn't want to comply with the stop and frisk, so they were like physically forced to be searched. Like maybe they were put on the ground or they were slammed up against a wall. And so here are the reasons as indicated by the reports, like by the crime statistics, like that were actually collected. These were on the police reports, right? Furtive movements, that means that they were like looking sneaky, maybe like slapping hands in a way that you could use to pass off drugs, maybe just kind of like creeping around, like looking like they had something in their pocket. Actions of engaging in a violent crime, like maybe they were trying to grab somebody's purse, right? Whether they were carrying like out in the open a suspicious object. Casing a victim or location can just be like standing on the street outside of that location or driving by multiple times. Fits a relevant description. I mean, we're looking for a suspect as a teenage male with dark hair. All right. That was me speaking into a police radio. I don't know if my miming was clear, right? But we go on and you can see that these are the reasons that police stopped them. Of those, about 50-50, more were frisked than not frisked, but it's pretty close. Why were they frisked? Mostly the same reasons they were stopped, although some of them were they were frisked because the officer said something to them and they didn't respond appropriately. And this is whether or not the officer used physical force. Mostly not force, but some force was used. But here's the part that made the difference in the Supreme Court case. For the outcomes, overwhelmingly, you'll find that the stops and frisks did not specifically lead to contraband being found, to weapons being found, in particular among weapons, to guns being found. This is 1,000 people though, this dot, just to throw it up there, it's not one person, it's 1,000. And whether or not a summons was issued, like they were asked to come to court at a later date, they weren't arrested, but they were said, hey, here's a ticket, you need to come to court, and whether or not an arrest was made. So overwhelmingly, you can see that the outcomes did not suggest that the frisks, they were leading to some potentially negative police interactions, but they weren't necessarily leading to crimes being committed. But what they found was that this was showing that the police were using bias in who they were stopping. So the fact that we have mostly young Black men being stopped or young Hispanic men being stopped, and that they were being stopped in boroughs that were largely multiracial, as opposed to Staten Island, which has is very much occupied by white people. All right, so this is the data that was used to indicate that perhaps the police's choices in who they were stopping and frisking was biased, and that therefore when we talk about illegal search and seizure, we're talking about whether or not that probable cause was being met, and the police officer discretion was not necessarily being used consistently for all citizens. And so the reason I show this isn't because I'm trying to teach that stop and frisk was like a racist policy. What I'm trying to talk about is really the fact that that the math needed to talk about these things is not super rigorous. A little bit of average rate of change, a little bit of basic statistics, but by going through the process of analyzing publicly available data using just the skills that you have from entry-level courses, either in upper high school or in lower college, you're able to make an impact on, I don't know, on your community in the event that you wanted to use it. So I just wanted to show you a real world application of average rate of change that I thought might be compelling. So class is dismissed. If y'all have any questions or you want to stay and discuss, I'm here, but I'm going to stop recording, and I really do appreciate your time today.